Welcome everyone. The question that is shown on the screen, it is from the CBSE 2026 physics question paper. This is an assertion reason type of questions, and the question is, assertion is the cylindrical soft iron core in a moving coil galvanometer only makes magnetic field radial and does not affect the strength of the magnetic field. So firstly, I want to point it out this word soft iron core. Okay, what is soft iron? Soft iron. What is it? It is a ferromagnetic material. Ferromagnetic material. We know that if we know there is an uniform magnetic field lines, this is the uniform magnetic field. Now, if you place a substance made up of soft iron core, then what will happen? Around it, the magnetic field lines are getting influenced. Magnetic field lines are getting influenced. These are obviously make like this way. The density of the magnetic field lines within this soft iron core, within this soft made object is like this. Okay. So you will see that the magnetic field lines just intersect, just cut this this round shaped object radially, okay, or we can say normally, and that's why it becomes radially. Okay, so if you say that here is a galvanometer's internal construction is like this, and this is a north pole. Here is the galvanometer's internal construction, and it is the south pole. We know all these things, and here is a you know that here is a rectangular coil or a square shaped coil. Okay, and which is basically hang with the help of a string, and obviously here is spring is attached, and with that coil this pointer is attached. Okay, this is the pointer. Now if on this rectangular wireframe a cylindrical soft iron core like this is added, then what will happen? It will looking like this. If I want to see the top view from here, then how it looks like? It is looking like that. The top of the cylinder looking like a circle. Okay, so exactly the same type of phenomena, just like this is the magnetic field line, it hits it perpendicularly, passes through it like this way and coming out like this way. Okay, this is another magnetic field line, hits it perpendicularly and passes through it like this way and exits it like this way. This is the, we can say this is a normally, so it goes like this simply from the north pole to south pole, this from the north pole to south pole. This is another one, hits it like this way, and okay, let us say this is another one like this, let us say this is another one. Okay, so we have understood that the magnetic field lines strikes this cylindrical surface, which is from the top. If you see it, it will be looking like a circular, so it is radial. It is correct, somehow it is correct, but this is not correct. It does not affect the strength of the magnetic field. This is not correct, because soft iron core is ferromagnetic. So inside the soft iron, the magnetic field lines comes closer. That's why the magnetic field strength inside this ferromagnetic substance has increased. So here it is said it does not affect the strength of the magnetic field. No, the magnetic field strength has increased. So assertion is wrong in this point of view. Okay. Now, in a moving coil galvanometer, the plane of the coil is always perpendicular to the magnetic field. Always perpendicular to the magnetic field. Okay, the magnetic field lines are like this. Okay, the magnetic field lines are like this. Magnetic field lines are like this. I am drawing in this figure. Magnetic field lines like this. Now the plane of the coil. This is the plane of the coil, we can say, and is perpendicular to that of it. So obviously you have observed that, you have understood that it is not parallel. The area vector of the coil and the direction of the magnetic field lines are perpendicular to each other, not not parallel. Okay, not parallel. Their perpendicular plane of the coil is perpendicular to the magnetic field. Plane of the coil is perpendicular magnetic field. No, plane of the coil is somehow we can say the parallel to the magnetic field. Okay, let me draw a figure. It will be make you understood that if I say this is the coil, okay, and these are the pole pieces. I hope you will understood that this is the direction of the magnetic field and this is the direction of the area of the coil. So the direction of the magnetic field and direction of the area of the coil are, in this particular case they are parallel, but in this particular case they are perpendicular. In this figure 1 they are parallel, in this figure 2 they are perpendicular. Okay, so the word always, I have a problem with that particular word. Always is not. Okay, always it is not perpendicular. Okay, so the area vector is not always. Plane of the coil is also the same thing. So it is not that. So reason is also the false. So from this we can say option D is the correct option here. Thank you all of you.